right? But you are not answering her call. You have not joined the proper Edmodo group, and you have not attempted any quiz or assignment, and still you are not answering your counselor. See, and in the previous class, you have been got the evidence that I have updated the details of your Edmodo activities to all your counselors. So what you have done, what you have not done, who have been joined the Edmodo group, who have not joined the Edmodo group, already all these details has been updated to your counselors, right? So based upon your counselors feedback, I will be forwarding to your class teachers and then to the HOD sir, right? So based upon your counselor reports itself, the results will be get forward to your HOD sir, right? So please be in contact with your Edmodo activities and perform them. Just simply seeing the assignments and simply seeing the quizzes and just getting out. So what is the use of it? Giving the assignments and giving the quizzes only for yourself and for your sake, making yourself to study, right? Don't get just neglect the subjects. Refer the subjects. Anytime you, any moment you will be having the internals and you will be also having the externals. Why? Because you've been observing that all other universities and including our university is been conducting the exams already, right? And you people and your semester is also to be conducted. But where and when it may be getting late, but sure of they will be conducting the exams for you. Okay, so don't neglect your subjects and topics and activities that are being given by the staff. Right, coming to the last class, what we've been discussed in the last class is discussed about the architecture of the wireless LAN, right? Discussed about the advantages and disadvantages of the LAN, and when compared to the advantages, the challenges that we have to face with the wireless LAN while working with in the real time are very much high. So beating those challenges, we have to get the, and we have to get benefited with the advantages of the wireless LAN, right? Beating with the disadvantages and the challenges to be faced in real time.
Madam, you are muted.
Sorry. Processor. Okay.
Madam garu.
సార్ మీరు నన్ను కూడా మ్యూట్ చేసేస్తున్నారు అందరితో పాటు.
ఇప్పుడు చూడండి మేడం.
ఇప్పుడు ఓకే, మీరు మ్యూట్ చేసినప్పుడు నాకు కూడా మ్యూట్ అవుతుంది.
అదే వెంటనే అందుకనే వచ్చేసానండి. రైట్.
ఓకే ఓకే సరే. So in the previous class we discussed about advantages and disadvantages of the wireless LAN, and also discussed about the infrastructure architecture of the wireless LAN version of 802.11. So we'll have a revision of that particular topics, then we'll be moving to the ad hoc architecture of it, right? So gone with various disadvantages and advantages of the wireless LAN. Okay, so after discussing with sir, are you able to see my screen?
No, ma'am.
No,
No,
ma'am.
ma'am, it's loading.
It's still loading, ma'am.
Wait a minute. Is it visible now? Is my screen is visible now? Are you able to see my screen or not?
Yes, ma'am.
Okay,
Yes, ma'am.
right. So while discussing with the disadvantages, we decided that we have to face many number of challenges in the real-time world while working with the wireless LAN, even though it is going to be giving many more benefits for us, right? And coming with the 802 point version, it is being discussed and considered as a family member of 802 point XLAN version, right? It is the common family member of 802 point XLAN version, and it is going to be also having other versions which we already discussed in computer networks like Ethernet and the token ring of 802.3 and 802.4 respectively, right? 802.3 is the Ethernet, 802.5 is the token ring. Right. And this particular 802.11 IEEE standard of the wireless LAN has been introduced with the IEEE version of 1999. That is, it's been introduced in the year 1999, and along with that particular versions, all other versions are being came into existence. And the primary goal of this particular version, what you are been discussing, 802.11, is it is going to be a simple and robust one. And obviously, we discussed about the primary goal of the wireless LAN is to what is called as avoiding the cabling and having a tethering connectivity with the internet, right? Having the tethering connectivity with the internet even without any wires. Okay, so that particular goal, taking the goal as the reference, this 802.11 has been introduced for the simplest and robust functionality of it, and at the same time, it is going to be offering us both the time bounded and also the asynchronous services, both the time bounded and asynchronous services in communication in wireless. Okay, wireless LANs. And coming to this data versions, data speed and whatever it is, and this we know that this particular MAC layer is being able to working with this particular wireless LAN, and this particular MAC layer is going to be operating at a particular physical layer versions. Coming to this 802.11, it is going to be working in the frequency ranges of infrared and the SPRED spectrum. Okay, in the ranges of infrared and the SPRED spectrum, this particular 802.11 is going to be working over, and it is going to be having it is going to be offering the additional features like power management and handling the hidden nodes, and also to operate it worldwide. While operating over the globe or operating over at global version, it is going to be also maintaining the battery power maintenance and also the handling the different hidden nodes. It is going to be striving, or it is going to be what is called as netting with the hidden nodes, and it is going to be identifying those nodes and communicating with them in worldwide. And at the same time, it is going to be operating at a frequency band of 2.4 gigahertz ISM band, and it is to be chosen as the original standard. And the data rates pertaining to this 802.11 standard LAN is what is called as a required rate. Required, or the maximum required standard is 1 megabits per second. It's a mandatory one, and it is been taking as optional, which can be increased its speed from 1 megabits to the 2 megabits. That is the optional one, but the mandatory one is the 1 megabits per second. That's the data rate of the wireless LAN that we are being discussing. Right, and coming to the architecture versions of this 802.11, it is going to be offering two types of architectures. One is the what is called as infrastructure architecture, and another one is the ad hoc architecture. Coming to this infrastructure architecture, it is going to be having the different components like stations, and also the access points, and also the base station service sets. Okay, base service sets and whatever it is. See, in coming to this particular base service sets, or a particular a base service sets is consisting of particular access point. Okay, and these access points are going to communicating among with all other base station sets or base service stations. And a particular station, STA1, has been indicated here, comprising of BBS, that is nothing but the base service sets, base service sets that are being communicating with the access points, which is very similar to our what is called as base transceiver system, and also the mobile stations coming under base service transmit. Okay, base service system, base station systems in our GSM. So in the GSM architecture, we've been discussed that each and every BSS are being under control of, or BSS are being taking control of corresponding mobile stations that are being working with the base transceiver system. They are being communicating with the base station controller, which are getting communicated with the corresponding mobile switching center. In the similar way, here we are having the stations consisting of the base service sets, which are being communicating with the access points, these are being communicating with the external world with the help of the portal here. So with the given infrastructure architecture, we are having two station sets, which are coming under a particular things called as ESS, extended service set. ESS is the extended service set, which is nothing but a particular group of stations, which are comprising of base service sets, having the access points to get communicated with. Combining all these access points to get communicated with the portal is called as the distribution system, which is having a communication system here, both communicating with the internal stations and also communicating with the external network, 802.x, another LAN, that is exclusive network, another exclusive network, which is being communicating with the interface called as portal here, right? This is the architecture, this is how we are being communicating with, right? We are being given with 802.11 LAN. That is a LAN version of 802.11 consisting of an access point AP, BSS called as base service set, and a station. So a station is going to be get comprised of BSS, lot of BSS that are being communicating with the access points. Okay, they are being communicating with the external stations or external 802.11 version with these access points, forming the distribution system. And all this set of LAN versions forming the extended service set, ESS, are going to communicate with the external networks or another set of the external networks with the help of the portal as an interface. This ESS is going to be given with certain number called as ESSI. That is what discussed in the last class, right? So it has been provided with the infrastructure based or ad hoc based, and we are being provided with the STS and access points. Base service set is there, and distributed service system, which has been communicating with all the BSS, and extended service set, and it is having its own identifier. Without this particular ESS ID, we can't participate in the communication of the wireless LAN networks, right? And this particular IEEE 802.11 is going to be not only giving you the specific architecture, it is also going to be consisting of not only are being confined to a particular BSS, communicated with the access points, connected with the distribution system. It may also consisting of bridged IEEE LANs, wireless links, or any other networks, right? Okay, it may be a combination of a particular LANs, not only a particular wireless LANs itself, it may be consisting of any type of wireless links or any type of bridged IEEE LANs and whatever it is, or any other type of networks, right? And not only a communication will be happening, the particular APs, that is the access points, are going to be taking you with the synchronization within the BSS, supporting the power management, and also they are going to be providing you the medium access and also the corresponding supporting time-bounded services. That is not only the synchronous services, they are also providing you the asynchronous services with the help of the MAC, right? And coming to the ad hoc wireless LANs, that is architecture, another version of the architecture provided with the 802.11. We have seen the infrastructure architecture. Here it is the ad hoc architecture. So what is it has been, how it has been different with this particular ad hoc architecture with the corresponding infrastructure architecture. Here it is going to be having IBSSR being separately. That is, in the previous version, we are having only the BSS. Here we are having the IBSSs. So what are these IBSS? We are being considering this as both the, this particular IBSS are having the stations are being differently, right? STA1 is there, STA2 is there, STA3 is there. In that particular, what is called as infrastructure architecture, the stations are being differentiated with the BSSs and access points, right? stations are been different. All these particular stations are been considered as the 802.11, and here it is been like. But what here the ad hoc architecture is considered as IBSSS, but consisting of the multiple number of stations. Please make note of the differences of these two architectures. Infrastructure architecture is been having the individual BSS, having a particular stations individually communicating with the access points, and that particular station is being considered as the 802.11 LAN, which is communicating with the other LAN, and all these are being combinedly grouply called as ESS. And coming with our ad hoc architecture, there are different stations coming under a single particular stations, that is called as all the stations are been coming under IBSS. This IBSS is independent base service set, which is been communicating or which is making all the stations under its control to be get communicate with each other, right? There will not be any specific distribution system which is making to communicate with each other. No specific access points will be there, but they are going to be communicating with each other, and that particular type of communication system is being provided among themselves. Okay, not only a single station comes under BSS here, an IBSS is going to be consisting of a group of stations, STA1, STA2, STA3. They can communicate directly here, whereas they need the access points to communicate in the infrastructure version. But coming to our ad hoc version, the stations doesn't need any access points and the distribution systems in order to communicate with each other. That is the difference between the ad hoc version and also the corresponding the infrastructure version, right? This is another set. This set is having only the two stations they have been communicating with, and this is the IBSS. So what is the full form of the IBSS? IBSS is the independent base service set, right? So IBSS comprises a group of stations using the same radio frequency. They doesn't bother about, they can communicate directly with each other, right? Several IBSS can either be formed by the distance or based upon the frequencies. So the IBSS are going to be formed, these IBSS are going to be formed based upon the distance between the stations, or that is one of the criteria to form the IBSS, or depending upon the frequencies that they are going to share. If these frequencies fall into the same category, a single IBSS is going to be formed. Otherwise, if these stations are going to be not aparted according to the distance limit, then they are going to be following a forming a single IBSS. So based on the distance or on the frequency, they are going to be sharing, this particular IBSS are going to be formed. Okay, they are going to communicating with each other, right? And this particular 802.11 version, in this particular ad hoc network version, it is not going to be following any specific routing information and whatever it is, as similar to our Bluetooth and according to the HyperLAN version, how they are going to be forming with the nodes and how they are being communicating with each other. According to the connection they are going to be followed up, they are going to communicating. No specific routing will be there and no specific connections and will be there provided. According to no specific topology will be followed. Only whenever the communicating point comes under that particular station, they will be get connected with that and they are being communicating. That is the speciality of the ad hoc network, right? That is how you are going to be getting connected with the number of users. So how you people are being connecting to our class. So when compared to the previous version of the what is called as this Zoom version, this particular version that you are using now for our classes is being a unlimited version. That is, many number of users can communicate. Once and while they will get the connection to that link or a connection to our class, then they will be connecting. That's why you are been doing the mischievous things by giving the links to your friends, right? సో మీరు ఎలా అయితే ఇప్పుడు మీ ఫ్రెండ్స్కి ఇచ్చి మీరు క్లాస్ని డిస్టర్బ్ చేస్తున్నారో, అన్లిమిటెడ్ వెర్షన్స్కి వెళ్తున్నారో, ఎప్పుడైతే ఫ్రీక్వెన్సీ లింక్ అవైలబుల్గా ఉంటుందో, దోస్ పీపుల్ కెన్ గెట్ డైరెక్ట్లీ ఇన్ టు దిస్ పర్టిక్యులర్ links. That is the speciality of this ad hoc networks while getting with the communication networks, and also to get connected with the video conferences and video meetings and conference meetings or conference calls. How you are been getting and how you are been accommodating much number of people into your meetings. So that is the possibility of this particular ad hoc networks of 802.11 version. Right, and coming to the protocol stack architecture, that is the protocol architecture of the 802.11. So for get communicating and get accommodating these type of users into the communication without any wire, Okay, it is arranging the stations, it is arranging the access points, it is arranging the distributed systems to get communicate over with the infrastructure version and also the corresponding ad-hoc version. It has been adding many number of users for the communication network, right? So what it is doing, what sort of protocols it is going to use here. So this is the mobile terminal. Okay, for example, say we are been including the communication with the 2 points. One is the mobile terminal and another one is the fixed terminal. So the fixed terminal is going to be accessing the protocol stack like this. It's going to be having the application layer, TCP layer, IP layer, LLC, logic link control, 802.3 MAC, 802.3 physical layer. So it is going to be using the Ethernet here. As it has been a fixed terminal, it is going to be using the Ethernet, 802.3, 802.3, right? At the lower layers for communication. And infrastructure network, it is going to be using the infrastructure network to communicate with. So whenever you are going to use the infrastructure network to communicate in this 802.11 version, it do require the access point to connect with the other mobile terminal, right? So what we have discussed in the infrastructure architecture version, we do require the infrastructure network. For that one, we have to have the access points to get communicate with the mobile terminal, right? And what about the mobile stack here? So what is the mobile system or the mobile device which is been accessing with the fixed terminal? What sort of protocol stack it is going to be supported with? So it is going to have the application. It is going to have the TCP, IP, LLC, which is common with the fixed terminal also. And again, what it is going to do is, as it is with the wireless version of communication, and as it is with the wireless communication, and whereas this particular fixed terminal has been communicating with this infrastructure point with the fixed, wired communication, and our mobile terminal is in the wireless communication, and it is going to following our version of 802.11. Then it is going to following 802.11 MAC version and 802.11 physical layer version, right? So while communicating with this particular fixed terminal, our mobile terminal has to get access with this particular access point and also to work with the infrastructure network. That is, the stations has to get communicated with the access points, and all these are being under the control of the base service set, that is the BSS, right? This fixed terminal and the mobile terminal, this fixed terminal will be followed with a particular fixed BSS, whereas the mobile terminal is going to be moving over so that its BSS are going to be changing over. So while changing over, this BSS is going to be working, sorry, this mobile terminal is going to working with 802.11 MAC and 802.11 physical. And this particular access point should work with, this access point has to get communicate with this mobile terminal which is moving over with the fixed terminal which is static here, right? So this particular access point has to work with which thing? It has to both work with 802.11 versions and also 802.3 versions, right? So that is how it is going to making compatibility in between the fixed terminal and also the mobile terminal. So as it is been working with the 802.3 version, that is the Ethernet version, and also the mobile terminal 802.11 MAC version, that is the wireless LAN version. So it has to communicate with this and also it has to communicate with this. In this way, it is going to be to and fro forwarding the information between the mobile terminal and the fixed terminal. This is how the protocol stack follows, right? So what sort of internal MAC protocols and the physical layer protocols do we follow with this mobile terminals? Already we know about this Ethernet and Ethernet protocols, how you are going to executing with the fixed terminals, how they are being communicating with the wired networks and all do we know. But how you are been communicating with the mobile terminals along with the fixed terminal, so that what sort of protocols are being available with this version of the 802.11 MAC and 802.11 physical terminal. Coming to this 802.11 MAC and the physical layer. See, what we are going to do, we are been communicating with the physical layer and the data link layer, right? See, data link control has been divided into the logical link control and the MAC. And we are been discussing about the MAC inversion. That is why, because this MAC is going to be acting as an interface between the logical link control and the physical layer, right? Right. So already we know about the MAC is going to be concerned about the MAC management. Already we discussed about that. And a physical layer is been following with which type of protocols to get communicate with the MAC here. So it is going to following two types of protocols here, PLCP and the PMD. So what are these PLCP and the PMD? So that it is being concerned with the physical management and the MAC management, so that they are going to be considered about the station management. Why? Because going back, This particular MAC and the physical layer are communicating with the access point. Access point is presenting in the infrastructure, and this particular access point is going to be concerned with a particular station, isn't it or not? In the infrastructure architecture, what we discussed about is this particular access points are belonging to a particular station. So station management has to be dealt with by this particular MAC layers and the physical layers. So that's why the station management has to be dealt with the MAC management and the physical layer management. These two has to take care about the station management. Until the station management has been handled by these two layers, the mobile terminal, which is having this protocol layer, couldn't get connected with the corresponding fixed terminal. While we are discussing about the communication between the mobile terminal and the fixed terminal, the mobile terminal has to get operated with this MAC and the physical layers. These particular MAC management and the physical layer management has to manage the station first. Then only they can communicate with the particular fixed terminal communication point, right? So this particular MAC management has to take care of the station management. In addition to that, the physical layer also has to take care of the physical layer management for the management of the station management. So combinedly, the data link layer with the help of the MAC and the physical layer with the help of this particular physical management, they are going to managing the station management to get connected with the physical terminal. And coming to the layers protocols, we'll see what could be these protocols. So we are seeing that 802 point is being seamlessly capable to get connected with other versions of 802.3. That is, we are being connecting with, right? We are being seen example like that. The mobile terminal has been connected with the fixed terminal, and the fixed terminal is engaging with the version of IEEE 802.3 Ethernet. That is what we discussed in the example. So that we can say that 802.11 version devices can be easily mingled with and easily compatible with the other versions of the 802.x LANs, right? So here the application shouldn't get any difference that they are been connecting to 802.3 version or 802.5 version or higher data versions or lower data versions and higher speed networks and lower speed networks. That difference shouldn't be identified by the mobile terminals which are using the 802.11. That is the speciality of the 802.11 version of the LAN. So that has to that care has to be taken by this 802.11 LAN version, seeming on masking that it is not going to be working with any type of difference in speed of the data rate. That is, the device which is going to be working with the 802.11 shouldn't notice any incompatibility with the communicating device. It shouldn't notice that whether it is communicating with the fixed terminal, whether it is communicating with the mobile terminal, whether it is communicating with the high data rate terminal or low data rate terminal, high bandwidth terminal or the low bandwidth terminal, or it is not, it shouldn't notice that in which communication media it is going to be working, whether it has been any objections are there from the communication media or a transmission media. All those things has to be get avoided. For that one, our IEEE 802.1 is going to be behaving like a slow wired LAN. There is nothing but a wired LAN version. How the wired LAN version is going to give you the uniform speed for all the communication devices. In the similar way, our 802.11 is going to give you that sort of service for you. Okay, and the higher layers are also going to working with the same type of wired nodes and the wireless nodes. Okay, and coming to the protocol layers. Okay. Are you able to see the screen now?
Yes, ma'am.
Okay, it's been disconnected in between. I don't know why it's happening. Right. So the physical layer has been divided into two types of protocols, that is PLCP and PMD. That is what we have seen in this diagram. That is the protocol architecture. The physical layer has been divided into PLCP, PMD, and it doesn't, no need of discuss about this particular MAC and the LLC. Already we discussed about the protocol architecture of MAC, right? So coming to this PLCP and the PMD, what is this PLCP as? Physical Layer Convergence Protocol, PLCP, and the Physical Medium Dependent, okay, or the what is called as Physical Medium Dependent Sublayer. So what are these two? What these two will be doing to get communicate with the station, or access point to get communicate our other party. So the basic tasks of the MAC layer, already we know about the medium access, fragmentation, and the encryption, right? It is going to be doing the authentication of our data and getting the sense of the medium, and fragmentation of the user data, that is dividing the data and sending out the what is called as transmission medium, and encrypting our data while sending to the other party. That is what we know. So that no need of discuss about the MAC. We have to discuss about how the physical layer is being engaging by that LAN. This PLCP sublayer is going to be sensing the signal. So how the MAC is going to be getting the services from the physical layer, even though the MAC is the sublayer of the data link layer, right? MAC is the sublayer of the data link layer. So it has to get the services from the physical layer. So that how it is going to be sensing the media. It is going to be, MAC layer is going to be compromising the medium access, fragmentation of the user data, and encryption. Where these services has to get it? As the MAC layer is being completely engaging in getting the connection with the other party, it is going to be forming the point-to-point connection. That is the exclusive use of the MAC. So other than that, it has to see that, it has to sense the medium, it has to fragment the data, and it has to encrypt the data. Where this thing has to be happen, it has to happen at the lower layer of it. That is something with the physical layer. And the physical layer is available here with the two parts, that is the PLCP and the PMD. So what the PLCP is nothing but the physical layer convergence protocol, which is going to doing that carrier sensing called clear channel assessment. That is, it's going to giving you the acknowledgement that whether the channel is clear for you to send the data. So for what it has to do, it has to identify whether there is any carrier at that moment in the transmission medium. If it sends any carrier, it doesn't give you the signal of clear channel assessment, CCA. Otherwise, if the carrier is free at that moment, then you will be available with the signal called as CCA. And it is going to be giving you the corresponding service called as common physical service access point. That is, it is going to be give you service access point into the medium, to enter into the medium and to send the data from your side. That is, the MAC can be able to provide you the point-to-point connection from other party whenever the corresponding physical layer provides you the SAP. Using the SAP itself, the MAC is going to be entering into the physical medium to transmit your data. How? Whenever this particular SAP will be given to you, whenever CCA is available, then only you will be given with the SAP and you can go for the transmission, right? So that is the responsibility of the PLCP now. And coming to the PMD, there is nothing but physical medium sublayer, physical medium dependent sublayer. What it is going to do is it's going to be handling the modulation, coding and decoding of the signal. That is nothing but enhancing or boosting of your signal, and at the same time encryption of your signals will be handled by the PMD, right? Apart from this particular sublayers, the corresponding MAC is going to give you the MAC management. That is already we have saw the architecture here, the MAC management and the physical management. So the MAC management, what the MAC management is going to be doing? It is going to be doing the maintenance of the data, like association and reassociation of the access points and roaming points whenever you are being connecting to what is authentication mechanisms, encryption, synchronization. All these things will be maintaining of the battery power. Everything will be managed. So where the information will be managed is nothing but this information is going to be managing by the MAC management version in a database called as MAC management information base, that is a MIB. So MAC is going to managing a particular log called as MAC management information base, MIB, in the section of MAC management. What it is going to do is associating and reassociating with the stations and roaming details, synchronization, encryption, authentication, power management. All these details pertaining to the stations will be get recorded in the MIB. Okay, all are going to be get recorded in the MIB by the MAC management. And the similar way, the physical management is going to be including with channel tuning and physical MIB maintenance, channel tuning and the physical MAB maintenance. So finally, the station management interacts with both the management layers of the physical layer and the MAC layer. Okay, so that is what we have saw here, right? The station management is going to be interacting with both the MAC management and the physical management. The MAC management is going to maintaining the MIB, which is going to maintaining the station associations, authentication, authorizations, power management, and how they are being getting associated with each other. All these are going to be managed with the MIB by the MAC management. And physical management subsection, physical management service of this particular physical layer is going to managing again the physical IB, that is nothing but the physical information base, which is going to taking care of the channel tuning and modulation and also the demodulation of the signals. All those data will be maintained in the physical IAB, PHY-IB. MIB is going to managing the MAC data, and physical PHY-IB is going to maintaining the physical channels tuning information, modulation and demodulation information, encoding and decoding information. All this information will be get engaged and get connected with the station management version from the access points. Right? Both management layers are responsible for additional higher layer functions. Okay. So I'm clear. I think I am clear about this particular layers, the versions, like that is called as both the infrastructure versions and also this is the infrastructure version of the MAC, right? That is 802.11 version, where the stations are being individually managed as the base service sets with the access points, and all those are being communicating with these access points, forming the distribution system. As a group, they are being considered as the extended service set. They are being communicating with the external LANs with the portal as an interface. Okay, and coming to the corresponding ad hoc version, instead of a single station, group of stations are being formed as the IBSS, independent base services. They can communicate directly with among themselves without any access points. That is the version of the ad hoc. Okay, and coming to this particular protocol stack of this particular 802.11, any type of mobile terminal accessing with the 802.11 version at the level of the MAC and physical layer get communicate with any type of the or any family member of 802.3, 802.5, whatever the LAN version, they can communicate. Whether it may be wired version or the wireless version, they can communicate with any family number if the particular mobile is going to be using the 802.11 wireless LAN version. Whereas this MAC and physical layers are being provided with different protocol layers in order to communicate with. Right here, we have been given with an example of working with the infrastructure architecture as we are being communicating with the fixed terminal, whereas these access points are being responsible for get communicated place association in between the mobile terminal and the physical terminal. These access points are being wholly responsible for making communicate with this mobile terminal and the fixed terminal. And coming to our protocol stack, the physical layer is being divided into two versions, PLCP, that is physical layer convergence protocol, where it is taking care of that, how the channel is been sensing, how the channel's acknowledgement has to be given to the particular MAC, then only the MAC can be sent to the data to the other party, right? This PLCP has been responsible for sensing the carrier and clearing the channel for us and providing you the service access point to enter into the transmission medium to send the data. All this CC and SAP will be get acknowledged back to the MAC sublayer. Okay, then only the MAC can enter into the scene and send the data to the other party. And in addition to these two services, the MAC and the PMD layers, whereas the PMD has been handling the modulation and decoding of the signals at the lowest level, or at the hardware level. And coming to the MAC management and the physical management layers of this particular physical layer and the MAC layer, they are taking care about the MAC log, including the authentication and accessing roaming points, synchronization, battery management, and the power management will be get logged by the MAC separately within the MIB, MAC management information base. And the physical management is going to taking care about the channel tuning and also the corresponding physical MIB maintenance. Okay, that particular thing will be maintained in the physical station, and these two will be get interacted with the station management in order to interact with the corresponding terminals. Okay, This is how the Mac is going to be working with the different versions of multiple accessings, that is SDMA, SDMA, TDMA, and the different versions of the things that we have been discussed. And finally, we discussed about 802.11, how it has been accommodating, how it has been working with the wired LANs and the wireless LANs. So with this, we have been completed with the second unit, that is the motivation for the Mac and also the working with the 802.11 in conjunction with the or in combination with the Mac. So this is how the wireless LANs has been induced into our advanced version of communication in mobile communication. So how you are been considering about the mobile communication and all those things. So this is how we have been completed the second unit. I will be posting you the second part of this 802.11 version in your Edmodo, and also the summary sheet of the second unit for your reference of the second unit topics. It could be indexed for the topics of the second unit, so you can easily refer. And from the next class onwards, we will be moving to the third unit, and the third unit is concerned with the IP layer. We discussed about this data link layer subversion, that is MAC, and how that particular IP layer will give you the services for the mobile communication, right? We'll be discussing about the IP layer in detail from the third unit. From the next class onwards, we'll be doing that. So until and unless we'll be given with the dates, okay, or dates of our internal, we'll be go with the syllabus, and I'll be going with the syllabus. You have to refer the topics. So whenever he will be announcing the dates, immediately we'll be having the exams. So they will not be giving any time for your preparation. So thoroughly prepare thoroughly with your exam syllabus with all the subjects. Get prepared for the examination. Whenever they will be announcing the dates, we have to write the you have to write the exams. Okay, there will not be any excuses. But how the arrangements will be there, how they will be conducting the exams, they will be giving you the detailed instructions. And coming to the second quiz of your mobile computing, today is the last date, I think. Okay, so go through the quiz and submit the quiz. Everybody do that before the due date. After the due date, it will be getting locked. Okay, so time is up. I will be ending the session. Please refer the syllabus of all the subjects. Whenever the dates have been announced for the internals, you will be immediately conducted with the exams. So there will not be time. So don't neglect the subjects. As you are the finalists, you have to also attempt with your training sessions. So don't miss the training sessions until and otherwise. If you are not going with these training sessions, if you go out and if you are going to trying after your final year, after completing of your final years, if you want to get the training, it is not that much of a possible to get that particular training in the external or the real time. So get acquainted with the available services that are provided by the college, use the services, and make it helpful for your career endeavors. Okay. I'm ending the session.